Okay. Can you see the screen with the slides, and can you see the recording on, Kaushal?
Yes, ma'am.
Yes. Yeah. Okay. Good morning, everybody. So we'll be continuing our discussion on pointers today, and this will be our last lecture for pointers. When we meet for the next class, we'll be talking about structures and then structures and pointers. So okay, so just to recap, the last discussion that we were having was about this function malloc, which is the memory allocator. This function will allocate as much memory as you ask it to allocate in terms of number of bytes. And the syntax of this is that you are going to give to malloc the number of bytes that you want to allocate, and it will return a pointer to void star. So therefore, in order to make sure that you are able to access the memory that you have allocated appropriately, you need to typecast this, and it is the responsibility of the caller to typecast the void star pointer appropriately. So if it is an integer memory location that you have allocated for integers, then you will typecast it as int star, or you will typecast it as char star, and so on. So we have seen that even if you have taken an integer x for allocated memory for a single variable x, which is an integer, you are going to typecast it as int star. Similarly, even if you have allocated memory for an array of integers, still you are going to typecast it as int star. The same thing happens for char star, and we are going to typically allocate memory for longer things or larger things like arrays, or further on when we go on, we'll have structures and so on. Okay, so the input, as I said, the input is the number of bytes. Very rarely we are going to say, give me 4 bytes, give me 10 bytes and so on. Typically the size is determined by the number of elements of a particular type, and therefore you are going to say size of int into, let's say, 10 if you want to allocate an integer array of size 10. And this memory that is obtained is destroyed only when it is explicitly freed using free, or when the program terminates. But we should have always a pointer to it if we want to access that memory. If we lose the pointer to it, we cannot access that memory, although the memory allocated exists for your program. So this is what we have seen. We have also seen an example of using malloc in yesterday's program. Today we are going to further see the use of malloc, and again exercise our use of pointers. So any questions here? Okay, so I assume that this thing is okay. So let's now take this following example where we want to write a function which does the following, that is, it returns the sum and average of the elements of an array. So yesterday you have written the recursive function which returns the average of the elements of an array. We would like to write any function. I mean, it doesn't have to be recursive. It is going to be iterative. Just so this is not about recursion. It is about returning two things using a function. So how do we do this? Any thoughts? I hope the problem is clear. The input is an array. We'll give the array as well as the size of the array. We would like to return the sum as well as the average of the elements using that function.
Is it through recursive functions? Yeah.
No, so as I said, the point today, I mean, the discussion today is not about recursive functions. It doesn't, in fact, let's just think about iterative functions. The function can be anything, but let's say we want to return the sum and average, and let's stick to iterative function. So it is, the function is clear. Inside the function, you can certainly compute the sum and average by going over the arrays and printing, I mean, and finding the sum and the average. That is not difficult. The question is, how do you return these two things? So we have two return things that we want to return. One is the sum, the other is the average. So we do not, I mean, there is no way for functions to return two values as of now. So how do you return this?
And we can use malloc to allocate two spaces and then return a pointer to the first place.
Okay. So we'll come to your solution, Gitartha. Any other thing? Gitartha is suggesting that we will use malloc, we will allocate memory and then return the pointers to those things, right? That is the overall idea, which is correct. The implementation of that requires some work, but yeah, that is a correct thought. Any other way of returning two things? I mean, one thing you can return. So let's say that the prototype, I mean, the return value of the function is going to be sum. So you don't have to care about how to return sum. So sum can be easily returned as the return value from the function. That is not difficult. Any other way of returning other than what Gitartha suggested? Are people, I mean, is it very difficult or is it too easy? Okay, so one of you has said pointers, but just saying pointers, I don't understand what is the idea that you have. So if you have any other idea, please tell me. Okay, so I'm going to present one solution. So the solution is inspired by the fact that, remember that when you have passed something from main to main, when you wanted to swap two variables, you were able to pass addresses of it and you were able to change those values inside that. So I think one of you has given this solution which says that call by reference by passing a variable. So remember, C does not support call by reference, but yes, using pointers, you are simulating call by reference. So we are going to do that as one of the first solutions and then see different ways of solving this. So let's read this program. So let's start reading it from main. So there is an integer array which is defined, which is of size 5 and there are 5 elements. So the sum is 15, the average is 3. There is nothing about the sum and the average. So what we are doing is we are having this int sum, which is in which we want the sum of the elements, and in this mean we want the average of these. So we have defined these two variables. What this means is space for these two has been allocated in main, and what we are going to do in this sum average function is going to pass the array, which is fine, which is the array that we are passing. The size of the array, all of this is easy. The third parameter to this is something which is a place in which you can return the values. So if you just say mean, if you just simply pass mean to this, then we know that even if this program writes, I mean, if I had just passed mean to it and said in the function prototype float avg, and avg is equal to sum over n, this is not going to get reflected. This we have seen multiple times in the swap function, so therefore that is not useful. So one correct way of doing this is to pass the address of mean, which is which has been allocated space in main. When this address is passed, of course you cannot have then this third parameter as just being a float. It is going to be a pointer to a floating point type float variable. So we have float star avg, and instead of saying avg is equal to or the average is equal to, we want to change the location that the caller has passed, which is the address of the variable, that is mean. So we are going to say star avg is equal to sum over n. So I also want you to look at the way this sum is computed. This is not difficult. You would have ideally written the following, that is for I is equal to 0 to I less than n I plus plus, sum is equal to sum plus a of I, that is a square bracket I. This is the way we access array elements. The only change that I am doing is accessing the array using the pointer notation. So we know that star of A points to A points to the first element of the array. So star of A is going to give me the first element, which is indexed as 0. So that is equal to A plus 0, and then I am taking the star of that. So it is exactly equal to star of A. The first and the second element is present at index 1, therefore it is A plus 1, and then it is going to, we are going to bring a star. Remember, A plus 1 is going to move it by move A or move the pointer by the appropriate number of bytes. Assuming that integers take 4 bytes, it is going to move the address to 4 bytes after A, and it is not changing A at all. A cannot be changed, that we have already seen. A is equal to A plus I cannot be done. So, but it is changing the pointer. It is accessing the element indexed at the first position, which is the second element of the array, and so on. So I just want you to observe this way of accessing the array elements, which is one difference from what we would have done. Ideally, we would have said A square bracket I. That is one point that I want you to observe. The second point that I want you to observe is that we are sending a parameter which is a pointer to some we are sending an argument which is a pointer, and using that we are trying to return a value to the caller by saying that star of avg is equal to sum over n. So this is one way of returning multiple values from a function. If you do not have other means, we will come to other means where we can club values and send some things. But at the moment when you do not have other means, you can use these pointers and send communicate multiple answers from a function. So any question here?
Ma'am, this might have been asked before, but the int star a, which is an argument of sum average, does that also behave like a constant pointer once it's initialized, or that's not a constant pointer?
No, it is not a constant pointer. So if you, in fact, if you change these elements, you are going to be able to change. So is the question you're asking is that, okay, so is the question that array elements, can it be modified via this function? Is that the question?
And ma'am, my question is, this int star a, there is an argument, ma'am, to sum average. Like we initialize it, we define some array, and then that starting location is given to this different
Yes.
pointer. Now this pointer is not constant, right? Within the scope of the function. Like you can change it, no, ma'am. We can move a, we can reinitialize a to something else.
Okay, so what I said, okay, so okay, I think what you are talking about is that I had said in one of the earlier these things that this array name cannot be changed. Yes, you are right. Here you can do a is equal to a plus 1. Yes, you can do that. This pointer can be moved. Yeah. Okay, so sorry, I should not have said it here that a is equal to a plus 1 cannot be done. In fact, the array name cannot be changed. For example, in main, you cannot say ARR is equal to ARR plus 1, but ARR plus I is a valid thing, or ARR plus 1 is a valid thing. So I think that is the question, right, Chinmay? Right?
Yes, ma'am. Inside the function scope, we can say statements like a is equal to a
this
plus
is a simple pointer to the integer. I mean, it is a simple pointer to an integer, and you can do a is equal to a plus 1. That is allowed. What I wanted to say, and I mistakenly said it in this context, I should have said that here you cannot do ARR is equal to ARR plus 1. That is not allowed. Yeah.
Okay, ma'am.
Yeah, you are right. And I repeat that, I mean, that this we have seen multiple times, that we can, I mean, if we change anything in the array, that is going to get reflected, because anyway, I mean, if you say something that you are going to change the elements of the array here, then they are anyway passed by reference, because we are sending the address of the array. So that we have seen multiple times when we have dealt with character arrays. Yeah. So any other question? Okay, so I want you to observe that the memory for the variable mean, that is the cell to store this floating point value, is allocated here by this statement. So we are saying that we have allocated space for this mean by this statement, which I have highlighted here. So all this is completely fine. In fact, when you print out the values, you will get 15 and 3 respectively. Okay, so we can keep the value of sum and average in a 2D array of two elements and just pass the address. Yeah. So you can do that. 2D array and all is not required. So one of the suggestions is, can you pass a 2D array of two elements and pass? Yes, you can do that. But what I wanted, yeah, this is same as saying that you are passing this float. I mean, with its address passed. So that is the same thing that you are suggesting, except that if you have a 2D array, you must have it as an array of floats, because one of the elements is going to be float, the other is going to be an integer. So you cannot have it as an integer array. Okay, so let's look at this program, which is a slide. Yes.
Why two-dimensional array? One-dimensional array.
Oh, sorry, not two-dimensional array. I thought 2D. Okay, sorry. Why did you say 2D? So Nanda Gopal, right? You said 2D array, not 2D. I thought two element array. Okay. Why 2D array? So
yeah, but like we could just without using pointers, we could just keep a like an array and then put this value of sum and average in that, and then actually we just keep a global pointer pointing to this address, and then we can just use it. So
do we need a global pointer? I mean, if you have, okay, so I think I completely misread the comment. So 2D, so first of all, do you mean a 2D array, Nanda Gopal? I mean, do you want to?
no, it's a 1D array. I actually
Yeah, so okay, I also read it as two element array. So I think I read it, and you also meant it as a two element array, and I also read it like that. But when I read it out aloud, I read it as what you had written, 2D array. So yeah, it need not be a 2D array. You just want two cells, right? You want two cells which have memory allocated, and they have memory allocated in main, and that is an array. Instead of that, what I have done is I have these two cells which are allocated memory. One is the mean, the other is the sum. In fact, sum need not even be having this thing, because sum is a return type, so that's okay. But mean requires this, right? So your solution is similar, except that you are saying that have an array. But what I disagree is that you don't need a global pointer. Is that right? Because arrays are themselves passed by reference, in the sense their addresses are passed. So when you change the values, you will get the answers in main also.
Okay, so ma'am, we can simply keep an array in the main function itself and then just pass it, and
yes, you can just pass. So let's say I have an array, a float, a answers, and then it has two elements, and then answers of 0 will contain sum and answers of 1 will contain the average. That is okay. And then your sum average can return that. I mean, can populate those values as long as you pass that as an answers array. Is that okay?
yes, ma'am.
Yeah. Okay. So I read it just not thinking too much, but I also interpreted it as two element array. Yeah. So that is a similar solution, which is fine. Okay. So I want to move ahead and ask you, let's read this program, which is very similar looking to what we had earlier, except that instead of saying float mean, I'm saying float star mean. And then of course I cannot say, I mean, I don't have to say and of mean, because otherwise it will be a type mismatch. So the sum average function has not changed at all. It has remained exactly the same. It is it has not changed at all, except the caller has done the following, that is float mean. It has instead of saying float mean, it has said float star mean. And therefore, instead of saying and of mean here, it is just sending the pointer. And it is here, instead of saying print mean, which would have been the floating point variable, it is saying star mean. So I want you to read this program and tell me whether it is correct syntactically, whether it is semantically correct. Note that there is no change in sum average. So it remains as it is. You don't have to worry about that. Sorry, there is a space missing here. This doesn't have any compile time issue, but it has readability issues. So if you see in the earlier program, the space tells you nicely, but there is a readability issue here. Okay, so please read the program carefully. Tell me whether it is correct first question is this syntactically correct? Is there a syntax error? If there is, what is the syntax error? If it is syntactically correct, then tell me, is there any issue when running this program? Okay, so some few replies are there, which are, it seem to be on the correct this thing. Okay, so when you write simply that it is correct, you mean that it is correct syntactically and semantically. If you write that it is correct, madam, then I assume that you are saying that it is correct syntactically as well as there is no error in terms of when the program executes. Okay. Okay, so I hope everybody got time to read the program carefully. There is no change from the previous program in sum average, so you don't have to worry about that. It is correctly computing the sum and the average, and there is no there's nothing erroneous there. Now let's look at the way main is executing this program. So main has an array which has been allocated space, which is good. Then there is a sum variable which has been allocated space. Now there is this variable which is float star mean. So it has given this space for mean. But remember that this is not the space where mean is going to get stored. This is a pointer. So this has been given space. However, you have not yet given space for mean to be stored. So this is an uninitialized pointer, and you have not said that, okay, the actual mean value is going to be stored in something. So there is no space given for a floating point data to be stored, right? So this is the picture that it is looking in main. When you go to when you are passing this, the mean itself, first of all, it is a call by value. So therefore this same address which is there, which is some bit pattern which is not initialized, therefore there is no memory, I mean there is nothing which is it is pointing to some random bit pattern or arbitrary bit pattern. That same thing is copied to this place which is this average. Okay, so yeah, so this was the story for mean in main. So this is mean and it is not initialized, so it is not pointing anywhere. The same address is going to get copied here, and it is going to start accessing that address when you do this following statement. So let's say you execute this following statement, that is star avg is equal to, still here the program is fine, it is not doing anything problematic. It is computing the sum. Sum is anyway a local variable here, so it is nicely computing that sum. Now when you try to access this star avg, it is going to go to this same copy which is not initialized and there is no space given to it, and trying to access the bit pattern that is here and interpret it as an address of a cell which will hold a floating point. You have never done anything to get memory, and therefore at this place you will get a seg fault. That is, you will most likely get a seg fault where you will access this random bit pattern and interpret it as the address of a cell which will hold a floating point variable, and therefore you will most likely get a segmentation fault when you execute this program. So the program is syntactically correct, but if you are trying to access this star avg, then it is the caller's responsibility to make sure that there is space for the floating point variable that you want to store, and that has been appropriately initialized. So you could have another line saying here float a, and then whatever mean is equal to and of a, and then it will work correctly. But then then it is the same as sending the address of a itself. So why do all of this? It will go back to the previous program. So is this clear to everybody?
Ma'am,
Yes.
there's a small document. Here actually, like if the pointer is not initialized, it will pointing to a garbage value, ma'am.
So that's what I'm saying. It will contain some bit pattern, right? It is having some bit pattern, and that bit pattern is interpreted as the address of a variable which will hold a floating point, because that is what it means by saying that float star mean. But you never initialized it to something, so it will contain some garbage. I mean, some kind of bit pattern which is garbage. In the sense, it is some bit pattern which we did not initialize.
Ma'am, so we can use Malloc to allocate memory for this.
Okay, good. I'm coming to that. That is the most natural thought. So I'll come to that. But before we go there, we will take questions if there are any. Yeah. Okay. Won't sum over n be an integer, as both of them are int? So it depends on what is the type, right? So it depends on what type it is. So as long as you have the, I mean, if okay, so let's that this question has nothing to do with the pointers. I think this question will be this question has to do with whether this will be an integer or a floating point. So if you say float f is equal to sum over n, then you will get a floating point value.
Ma'am?
Yes.
Ma'am, even if we don't get a fault in that region, mean is actually a pointer and float star AVG. So we have created 2 pointers that have not been initialized. So even if average gets changed, will mean get changed? Like if average is pointing to.
So that is what I'm coming to. So we'll come to that, right? Yeah. So these are 2 pointers, and that we have to remember. So that is a good question, and that is also in line with what one of you asked, where you said that can we allocate memory? Yeah. So I hope that everybody sees that this program is incorrect. Yeah. Does average point to garbage value? Yes, average also points to some garbage. It contains the same bit pattern that is present here. It will be copied here. Sorry, the annotation is gone. But the same bit pattern that was there in mean is going to get copied to AVG. Yeah, just the way we do. I mean, n is copied. Whatever is the bit pattern here is going to get copied to n. Same way. Any other question? Okay, so Gokul, you don't get why the program is incorrect. So, okay, so so just for the sake of making sure that all of us understand, Gokul may have raised this question, but many of you may have this. So, can you confirm that you can see my this thing? Yeah, so this is some AVG2. Which is this program. So yeah, can you please confirm that you are able to see my REPL, and I'm going to copy this into the visualizer.
Yes, ma'am.
Okay, thanks. Okay, so I am getting some noise from some of you. Please, yeah, please mute yourself. Okay, so this is the same program. I have just copied it here, and I hope you will be able to see the issue. So let's run this program. I mean, the initialization is not problematic. As you see that the mean, this question mark here is telling us that this mean pointer has not been initialized. So this question mark is telling us that sum has also not been initialized, but anyway, sum is not going to be used without being initialized. So sum is equal to sum average. So let's go to this sum AVG. It has this A pointer, which will be appropriately pointing to the array, N, which will be initialized, which is a copy of it. It is not pointing to anything. And AVG is the same pointer that is from mean, but since mean itself was not initialized, AVG is also not initialized, and sum is initialized to 0, I is initialized to 0. So these 5 iterations I can quickly skip because they will compute the sum, which will be correctly computed as 15. So till here everything should be fine. Now is the place where you are going to say that star AVG is equal to sum over n, but AVG is not initialized to anything. So when you do this star AVG, this is the line which is going to cause the problem. In fact, it must be showing some problem below. Yeah, so use of uninitialized value at this line, and that is why this will give a core dump when you try to run it on the REPL. So to people who had not understood, is this clear why this program is incorrect? Because we haven't taken the care to initialize or have space for this. So there is no memory allocated to store the value of mean. The mean pointer has value, but there is no place where you can store the value of mean. Yeah. So this program will most likely give you seg fault. So now let's go to the suggestions that you people have given, that you have this memory issue. So let's try to allocate memory for it in the, so we are stuck with this idea of somehow saying that I will not take care of allocating memory in the main, which we know how to do. So that we know, again, the example may be slightly contrived, but you will see why I'm bringing it out here. So we want to solve the memory issue. That is, the caller is not giving us memory allocated. So why not we allocate it in the sum average? So let's solve this memory issue. So then let's say we are going to allocate memory. And again, the reason I have done this malloc is you want to see some examples of malloc with different data types. So we are now initializing it with size of float, because we want a floating point memory location. And now we are going to typecast it using the appropriate data type, which is float star. And then this part remains the same. Now star AVG is equal to sum over n. So this seems to be now addressing the memory issue that we had, that is memory was not obtained. So now this star AVG is a correct access because we have memory for storing that float. So now please read the program and tell me whether it is a correct program. Please do not unmute yourself. Let everybody think about it and you can answer it in the chat messages. That is what I want you to tell me is that when I do a printf %d %f here in main, will I get 3 and 15 and 3 respectively? Okay, so if you say not correct, you should also tell us why it is not correct in the chat itself, so that you don't spoil the fun for everybody else. So I have 3 answers till now. Yes, so people who have got it, they have got it right. Good. Yeah, so Shashank, I will come to your answer. Okay, so good. So people have pointed out, many of you have pointed out, not many I should say, but yeah. So some of you have pointed out the error correctly. So okay, so one of the questions I would like to address. So when we declare a pointer, memory is already allocated to that. Then why do we allocate memory again? So here, this question I think deserves an answer here on this annotation. So as I repeat, when we have allocated memory for the yeah, so when we have allocated memory for this by saying float star mean, we have allocated this cell to hold the pointer. and this is holding this pointer. In the sense, there is no arrow, of course, but whatever is this cell is going to be interpreted as the address of a variable or address of a cell which will hold a floating point variable, right? So we have allocated space for this, but we have not allocated space to store the floating point variable itself, right? So that is why we need malloc, and we have done the malloc correctly. There is no problem here. So the segmentation fault is no longer occurring at this place where it was occurring earlier. That is, this star avg is equal to sum over n is now a very valid statement, because avg is indeed having memory. I mean, avg is pointing to a cell which is being allocated. This memory will be allocated on the heap, and we can modify it. That is what this program also tells us. So till here the program is fine, but note that we have call by value for all the variables. So whenever this mean is the pointer that you wanted to modify, when you wanted to you sent it to this sum avg, it is call by value, so that bit pattern is copied, and the local parameter here, which is called avg, is the one which is getting changed, and that is something that gets erased when the function goes out of scope, or it finishes execution. So I will take a minute to do this execution again on the visualizer, because it is instructive to do so. So I think this is some avg3. Yeah. Okay, so this is the new program which we have seen. Oh, sorry, I think I have not copied the correct program. It does not have a malloc. Yeah, so now when we execute this, you will see that AVG star AVG here is a fine piece of code, because that has correct memory. Okay, so I'm going to quickly go over this, which we know how to do. So yeah, so now if you see this AVG, okay, so I don't know why this AVG did not get. Okay, so I'm sorry, I don't know why this code is not behaving that way. So AVG is equal to float star. Yeah, so I'm just going to run it again. Okay, I'm really surprised why this doesn't show you what it is supposed to show. So Kaushal, do you see some mistake that I'm doing? I mean, obviously something that I'm missing, and why is this AVG pointer not getting initialized? Yeah, so this, I mean, ideally this should show us the malloc, but Okay, so I really don't know why this statement is not getting executed. If anybody sees any obvious problem that I'm having with my execution, please let me know. But anyway, the point is that here this should have actually pointed this to, I mean, this should have actually done the job of allocating space on the heap. Okay, so let me just try out this statement here in main. I don't know why this allocation is not happening.
And also the error didn't come normally. Error of
Yeah, there is no error, and I think I had tried this earlier before the class and it did show it. I am very surprised why this visualizer is behaving in a slightly weird way, where it is not allocating that and it did not show any error. Yeah. So let's see whether this at least, yeah. So as you see, the mean has been appropriately allocated space. So let's see whether it does it now for the, yeah, okay. So I think there was a problem with the visualizer. I hope it was not my execution problem. But anyway, as you see this, right, there is a memory that we have allocated uh, for this as well as yeah. Now the problem that I see here is that it is both of them are pointing to the same memory. This is also not what it should be happening. So I'm sorry, this visualizer has gone really bonkers. Okay, I will try to show what I wanted to show once again. Otherwise, we'll skip this visualization. Okay. Okay, so I give up here on this visualizer. It doesn't show me what I want you to observe. So I'll go back to the slide and I'll explain it only using that. So of course, AVG, this part gives the memory to the memory that we want. And therefore this statement is okay. However, because this is called by value, therefore this is not getting copied to this mean. Therefore, this mean still remains uninitialized. And when we try to print out star mean, we are going to have this segmentation fault. So this is the issue with this program, which is allocating space, but it is not still initializing the pointer mean, which is in main. So of course, if you do allocation in main, that it will solve the problem, but you should be accessing the same memory. In that case, you should not be allocating space in the sum AVG. So what I want to point out from here is that in the first problem, first solution that we had, which was this, yeah, where we wanted to change the mean, that is the floating point variable itself, we send the address of the floating point variable. Now, in this case, this solution that we want to implement, we want to change the pointer value, in which case you must send the address of the pointer. Therefore, you should be sending and of mean, in which case your function prototype has to change. You will have to say float star star AVG, and that will be a pointer to a floating point value. That is, it is an address of a variable which is a pointer to a floating point value, which is exactly and of mean. And now, instead of saying AVG is equal to float star, it is going to say star AVG is equal to float star malloc. So note the change here. That is, it is not saying AVG is equal to float star, but it is saying star AVG is equal to float star, which will change the pointer which you have, for which you have allocated space in main, and then you are able to access this as star mean. So this is one of the ways of solving another way of solving this problem, which we had solved it in the first slide itself using the and mean, which is a correct thing, where you had just taken a float mean. But why I wanted to go over this is to understand why the other solutions were incorrect and what is happening because of call by value. So I leave it to you to stare at this program carefully. The changes in the program are in the prototype of this function, which is changed. Therefore, instead of saying avg is equal to this, you are going to say star avg is equal to the appropriate pointer, and then you are going to say star star avg is equal to sum over n. So these are the changes that we have made in the program, and we have also changed the way it has been called. So this is another way of doing this. This is indeed a contrived way of solving this problem, but why this is required will be why this is, I mean, why I am illustrating this will be hopefully useful when we are going to deal with structures and pointers and therefore linked list. Okay, can we use malloc in main and skip using malloc in the function? Yes, you can use malloc in the main and skip using malloc in the function, but that is as good as saying that you are allocating space for a variable. So as I said, the first solution is the easiest solution here, which we had, where we are saying that and of main is, so it is same as saying that you have this, but you have it on your function stack. That there's no problem as long as you have memory. Okay, so okay, Satyajit says I did not understand this, so I did not understand. I think it is the star variant that you did not understand. Okay, so I hope everybody got the fact. I mean, apologies for the time that was wasted in the visualizer, but I hope all of you see why this program doesn't work. That is solving the issue in malloc, solving the memory issue in this sum average is not a correct way. The program is okay till here, but the program is not okay to print out the mean value in main, because by the time, or when this program returns, this mean is something that you had passed by value, so it does not have the address of the memory that you have allocated. So that memory is there and it has been correctly initialized with the value of the average of those integers, but it is not useful because you don't have a pointer into it, because you never change this pointer, which is float star mean. Is this clear to people who are saying that the next version is not clear to them? If this is clear, then you should understand that you are trying to change the pointer, the contents of this pointer, which is this cell. Then you must have the address of the pointer. That is, therefore you are sending the address of this pointer. The address of this pointer has type, which is float star star avg. It is not float star avg, it is float star star avg, because it is the address of a variable which is a pointer to a float. Therefore it is float star star. Is that clear? Okay, and now that if this data type is clear to you, then you know that if you want to change, or if you want to change the cell that contains the address, then you should access this star avg. And if you want to change the actual floating point value, then you must access it as star star avg. So given this thing, I'll still attempt once more the visualization, because it was showing it in such a nice way that I am still surprised that why it doesn't show you in this. Okay, so I'll still attempt this, and this is the last part of the class. Okay, so I hope this first part is clear, that now we have sent a pointer to the array. We have also sent the address of the mean variable. That is why avg is no longer some pointer. It is actually the address of this. Therefore, it is pointing to mean. Now let's see what this, yeah, great. So this statement is indeed allocating memory, and this is the one which is in main, which is pointing to the memory allocated on the heap. And now when you further do sum, this part is something which is just changing the local sum here. Now this place where you are running star avg is equal to sum of sum over n. So star avg is going and pointing to mean. Star avg is taking this pointer, dereferencing this value, going to this value, and then setting 3 here. So let's see that that is happening. So that 3 is being set. Now you lose this avg pointer because this function finishes execution. All that stack is deleted, and all that you have is main, where you have sum is initialized, initialized to 15, and this mean pointer is pointing to the global, not global, the memory that we have allocated on the heap, and this pointer is something that we have. So this is what we wanted to achieve, and that we have achieved using a pointer to a pointer, and that is why we are able to correctly get this. Okay, so okay.
Ma'am, if we use malloc before that passing into that function, like for that mean in the main function, then ABG, like we can instead use star ABG, then ABG and mean will point to the same heap thing, ma'am. So if we alter that star ABG itself, then it will also, mean will also point to the same thing.
No, wait. So is one thing is, are you sending float star AVG, or it is floats?
Float star AVG, and we are passing mean, not passing and mean. We are passing mean.
Okay.
And
So it is the previous version. Okay,
yeah,
sure.
and in that, instead of putting malloc inside the sum AVG, we can put it before the passing into the function for mean, right?
Yes, that is correct, because that is anyway saying that it is the same as saying that you have allocated memory either using malloc, or you can allocate it using just a simple float f, right? That variable kind of thing. Yes,
Okay,
that is
like
perfectly fine.
so it is like the first version.
Yes, it is like the first version of the program. Yes, just using pointers.
Okay, okay.
Yeah, that is correct. But the intermediate version was incorrect, where the memory was being allocated in the this thing function, but because of the call by value, the caller doesn't have the address of the memory. So that was incorrect version. Yes. Okay. So the class is over. In today's lab, most likely you are not going to require malloc. Also, you are just going to require array access using pointers, which should be fairly easy. Even in yesterday's or even the previous class, we have done that. So you are going to simply require array access using using this pointer notation, which is kind of this. And I wanted to do matrix access using pointers, but I have run out of time. So I will possibly send you a small note or add that to the slide and give it to you in the slides itself. Don't worry too much about that. It is just for the sake of completeness. Today's lab won't require you to have matrix access using pointers. Okay, so I'm going to stop the recording. I'll see what questions people have, and then